Welcome, everyone. Thanks for joining. I'm just going to give it probably another minute for more people to join. I'm sure people are grabbing lunch or hopping off of another meeting. But as folks are joining, if they want to put in the chat where they're tuning in from, it's always nice to see like where we're pulling people from, and also makes me feel like I'm not just talking to myself and there's actually other people on the other side of the screen. A lot of people from my neck of the woods. Kind of fun. All right, it looks like we have a pretty full group of us, and I think in the interest of time, we have a fair amount to cover, so we should go ahead and get started. Thanks everyone so much for joining us for this Weatherization Wednesday focused on heat pumps. This is being put on as part of the Button Up campaign, which is Vermont's annual campaign to spread awareness about the benefits of weatherization and strategic heating electrification, so heat pumps. Just want to note that we are recording this webinar and it will be posted to Efficiency Vermont's YouTube afterward, and we'll also send an email to all registrants with the link to the recording as well as the slides as well. Okay, so my name is Becca Custer. I'm a community engagement manager at Efficiency Vermont and help to lead the Button Up campaign. And I'm very happy to be joined by my colleagues at Efficiency Vermont, Nate Gunnish, who's going to be leading today's presentation, and Bennett Doherty, who's going to be our Q&A person, really helping to make sure that all of your questions get answered. Before I turn it over to Nate, though, I do just want to run through some kind of webinar logistics and also share quickly who Efficiency Vermont is so you know who is putting on today's webinar. So thanks, Nate. Nate beat me to it. Efficiency Vermont is a statewide energy efficiency utility. So we serve every part of the state except for Burlington. And we help to reduce the cost of energy for all Vermonters and really help folks understand and make better use of energy and reduce greenhouse gases. We also are the sponsor and facilitator of the Button Up campaign, but we do have a lot of other partners across the state that support the campaign each year. Next slide. Also, I want to note that we are going to select a random name from today's attendee list to win a $50 gift card to a local hardware store. We're not going to do that drawing live, but we'll do it afterward, and you can expect an email from us in the coming days if you're that lucky winner. Last thing I'll say before I turn it over to Nate is that we are going to have the pretty chock full presentation. So we'll probably have like 10-ish or so minutes for Q&A. So please, as questions come up, put them in the Q&A function here on Zoom, not in the chat. And then if you're joining on Facebook, you can put your questions in the comments there. We're going to do our best to get to as many questions as possible. And Bennett's going to be answering the questions that are coming in live. And then for the last kind of 10 minutes, fully dedicated to Q&A, we'll make sure to address any questions that were pre-submitted during registration and then any kind of remaining questions that we're seeing come in through the Q&A. I'll also just quickly note that, we're probably going to get a lot of questions, or you all have a lot of questions about your specific kind of unique home situation, and we can try to do our best to get to those, but it's kind of a kind of challenging forum to answer those questions. So I'm going to ask you guys to definitely note the resources that Nate's going to detail later in the presentation, including taking advantage of a virtual home energy visit, calling our customer support, or also just connecting with a contractor directly to talk through your specific situation. That's probably a better forum for those very specific questions. So that is it for me, and I'll turn it over to you, Nate. Thanks for being here.
Okay, great. Thanks, Becca. I unmuted myself. Can you hear me? Okay, great. Awesome. Okay, cool. So let's get right into it. Heat pumps are a really popular topic of discussion. They're coming up a lot when we think about efficient heating for our homes. And really glad to get a good turnout here at this event and just demonstrating how many people are interested in these. So I'm excited to talk about them. I will say right off the bat that we are going to talk about primarily heat pumps and whether they're right for you, as in whether they are right for your home right now, right? So I'm going to be focusing on existing homes. A lot of the topics and principles that we'll talk about today will directly relate to new construction as well. But I think that some of the challenges around heat pumps come when we're approaching an existing building that, didn't have heat pumps originally, and that makes it kind of tricky to move forward. So we're going to talk about how you can approach that challenge, what kind of heat pumps are going to be right for you, and how to make it work best for you. So let's get into it. What we want you to know, right? So I'm laying this out just kind of as some signposts, what we're going to talk about throughout this presentation. That way you have some structure to follow along with. And also, these are just kind of some of the targets. If you walk away with these 4 things, then I'll have been successful. So we'll talk about heating system fundamentals really quickly, kind of breeze through that. It'll be review for most people, but the idea is just to establish, okay, this is what you have. Before we talk about what you're trying to get to, because that's going to be helpful in understanding how these systems work, and it's going to impact what you can do in the future. Then we'll talk about what a heat pump is and how it works. I'm also going to move through that a little quickly. There are a lot of good resources out there. You're welcome to reach out to Efficiency Vermont to learn more about how heat pumps work. But I'll talk about that quickly just so we're kind of all on the same page. I'll have the same vocabulary and whatnot. And then they'll spend the bulk of the time talking about the types of heat pumps that could be suitable for your home. This will be, I think, interesting to a lot of people. And lastly, I'll just end with some next steps, some questions for contractors, and some of the resources that we have available. This questions for contractors things is something that matters to me, as I'll probably reference throughout. Having the right vocabulary to have a conversation with a contractor and ask informed questions, refer to your equipment type in the correct way. All of these things are really important when you're pursuing heat pumps to make sure it's a streamlined and effective process, that you have a good customer service experience and all of the above. So we'll definitely talk about kind of vocabulary and questions for contractors throughout. A good place for you to start. So that's where I am, but where are you going to start? I think if you're going to take down notes, this is what you should write down. I think these 6 questions are really important for every homeowner who's considering heat pumps. If you can at least think about these questions for yourself, you're going to be in a better position than a person who kind of comes in totally unprepared. So these are, what are your goals? And by that, I sort of mean, what are you trying to change in your home, right? Is your system really old? Do you need air conditioning? Are you trying to get off of fossil fuels? There are a variety of different goals that could lead you to heat pumps. So, and depending on what those are, those might kind of push you in a different direction. What are your comfort needs? As I mentioned, air conditioning, right? That's a big one for people. Another thing we'll talk about throughout is different heat pump systems have sort of different levels of distribution throughout the home, and that's going to kind of change a little bit of occupant comfort. So that's another thing to keep in mind. What your house is like, what your distribution system is, and how much weatherization has been done. These 3 questions all kind of go hand in hand. We'll talk about some of the physical layouts of a lot of homes, what yours might be like. Again, if you have sort of specific questions about your home, we'll give resources so you guys can reach out to Efficiency Vermont directly, get myself or one of my colleagues on the phone and kind of talk about some of those details. The distribution system you have is going to impact what kind of heat pump you can go for, the weatherization that's been done. All of these things are kind of the physical attributes of the home, and that's going to impact your decision making. And lastly, what's your budget? I think that's an important one as well. I'll give a quick breakdown of sort of what systems, how systems kind of stack up against each other from a cost standpoint. Okay, getting to the first section here, let's talk about traditional fuel-fired heating. This is what most of us have in our homes. This is how we've heated for a long, long time. And let's talk about the different types that are out there. So first I want to mention boilers, right? So boilers are super common in Vermont. A lot of older homes have boilers. The hallmark of a boiler is water distribution, right? You're burning fuel to heat up water and then distributing that water throughout the house. That's going to get distributed around through pipes. There will be a pump probably and valves. The hot water will eventually end up in radiators or baseboards, or for some homes, heated floors or radiant slabs. Those are all kind of, we refer to those as emitters, right? Where the heat comes from. Those are your radiators and your baseboards. And then I'll mention that these boilers sometimes provide domestic hot water heating as well. They can be kind of a comprehensive system. And yeah, again, you're burning fuel. That fuel could be gas, natural gas. It could be propane. It could be oil. It could be wood pellets. There's a variety of different systems out there, but you're burning something to heat up water and send that water throughout the house. Then let's mention furnaces, right? So furnaces are another really common type of fuel-fired heating system. They differ from boilers in that they use air to distribute heat throughout the house, right? So again, you're burning a fuel, could be those same types of fuel I just mentioned, oil or propane, and then running a fan across where that fuel is being burnt to distribute heat throughout the house. And again, these are super common. People are going to be really familiar with these. If you don't know which one of these you have, you can look around. Do I have radiators or do I have these, some kind of grill or register? This bottom photo I have somewhere where the hot air comes out, and the air moves throughout the house through ductwork, right? So often that's shiny sheet metal stuff. It can be a variety of different things, but hopefully it's the shiny sheet metal stuff. So again, these are your two kind of distributed fuel fired heating systems. I'll also mention non-distributed fuel-fired heat. So this could be a space heater or a wood stove. A lot of rental properties have space heaters. A lot of single-family homes have space heaters. These may burn gas or propane. They're just mounted right on the wall. Wood stove, on the other hand, again, a lot of us are super familiar with these. They could burn pellets. So the thing here is there's no distribution, right? So there's no water or air being blown around the house or moved around the house. So you just have one place where the heat is coming from. And that's warming up the room where it is. And then ideally, it starts to warm up some adjacent rooms as well. So again, this is a non-distributed heating system, but that one that burns fuel, right? So these are kind of our what we see in a lot of homes already. And just a quick overview here. These systems are using really high temperatures to heat our homes, right? So this first bullet here, high temperature distribution via air or water. This is an important one. I'll come back to this quite a bit. The point that I want to make here is that because we're burning fuel, we're producing really high temperatures. And as I'll talk about shortly, heat pumps are going to they're still warm, right? They're still producing heat, but the temperatures are not going to be quite as high. So that's going to impact how we distribute that heat around the house. I'll get into the details of that shortly, but just keep that in mind that these are high temperature systems. Obviously, they don't provide cooling. They can be subject to volatile fuel pricing, kind of depends on the fuel, but we've seen that more and more recently. And of course, these systems are, sources of carbon emissions and other air pollutants that could be air pollutants right into the home where you're living and you and your family are living, and then also CO2 into the atmosphere. So just again, kind of a breakdown of what you have. Let's talk about where we're going. So what about heat pumps, right? So heat pumps are familiar to a lot of us. Some of us may not know anything about them, right? So I include this photo here, just kind of a blank cutout. So, you can picture, oh, I've driven past my neighbor and they have one of those. I guess I have seen where a heat pump is, right? So this is an outdoor unit. I'll talk a little bit more about the anatomy of one of these as we go. But yeah, let's talk about what makes these different from other systems, and why are people interested in them, right? Why would you be interested in them? Let's get into it. So starting here with some of the high level characteristics, right? So heat pumps, they run on electricity. And it's worth mentioning that they are both heating and cooling systems, right? So these systems, talk about this on the next slide, they are able to both cool and heat your home. They basically can do the same process and then reverse it, right? So they can run in both directions. And then they are all add much more efficient than electric resistance heating. I think this is something that a lot of us know, but is worth reiterating because we have heard for a long time that electric resistance or electric heating is expensive. Okay, you're telling me these run on electricity. Isn't that going to be expensive to operate? But because these systems are so much more efficient, often 2 to 4 times more efficient than traditional electric systems, we end up saving a lot of money in the long run. So again, some of the high level characteristics here. how do they work, right? So let's talk about this a little bit. I'm gonna breeze through this a little bit. Like I said, there's a lot of good resources on our website, and you're welcome to reach out directly to Efficiency Vermont if you want to talk about this in more detail. But I think it's important to get a really high level understanding of what's going on here. Um, Fundamentally, we're trying to move heat from one space to another, right? That's what allows these to be much more efficient than traditional systems. Instead of creating heat in a space, we're moving it from one area to another. And that we can do with electricity. We are relying on electric components and something called refrigerant, right? So this is the same technology that's in a refrigerator in traditional air conditioning systems, refrigerant technology, and we're using those systems to move this refrigerant from one space to another. A really important principle here is that heat always moves to cold, right? So if you put a cool liquid in a warm space, the heat from that warm space is going to get sucked into that cool liquid. That's a really important kind of physics principle behind how these heat pumps work. So if we think about how these are working for our homes to heat up our homes, if we're able to get that liquid that's running outside really cold, even on a cold day, it's still able to extract, uh, heat energy from that outdoor space, and then bring that into the home. And then again, through the refrigerant cycle, we're able to change how that material, the temperature of that material, bring it into the house, and then you're able to warm up the house, right? So that's again what we're doing here. We're using physics to our advantage, trying to concentrate heat in one space and move it to another. Again, it works to take the heat from in your house and dump it outside in the summer, and in the winter, take the heat from outside and move it into the house. I'll throw up here just a couple little illustrations here of the type of systems that work. There are a variety of different ways to concentrate and extract that heat from outside. You can do it from the air. You can do it from below the ground. There's a few different types of units. I'll talk about those different systems in detail as we go. But again, you're typically pulling that heat from the air or from below the ground. And then, of course, in the indoors, we have to move that heat around. Again, we're going to get a full breakdown here, but it can work in a variety of different ways. We'll talk about this. You can use what we kind of typically think of as heat pumps, these wall-mounted units, and then we can also distribute that heat around through hot water or through ductwork. Just kind of demonstrating that here with this little thing. You can take a screenshot of this one if you kind of want a diagram of how these things work. I'll mention here that something I already said. So heat pumps, they have a lower temperature of distribution compared to fuel-fired systems, right? So these that's going to affect how our distribution networks are designed and how they're done. And we'll talk about that in a little more detail, but that's why I just want to establish that right now. They're going to have lower temperature distribution throughout the house. Another thing that's worth just getting out of the way is that heat pumps do work, right? So even in our cold Vermont winters, a well-designed heat pump system can heat your home. And this can get down to some really cold temperatures, and these can continue operating. They will lose efficiency at lower temperature, and they'll lose some of their capacity at lower temperature. But over the last few years, manufacturers have really worked on designing systems that are capable of continuing to function and produce heat even when it's very, very cold outside. I'll mention that if you're considering buying these, you want to make sure you buy cold climate units. That matters a lot. You want to get the systems that are designed to operate down to -13, -17 degrees outdoor. And you want to make sure you're going for the right type of system. And then I'll say that if you have a very energy efficient home, you could likely heat your entire home with just heat pumps, but you have to have a really good thermal envelope. In existing homes, you'll have to have had a lot of weatherization work done, very likely, and or this could be in a new construction application. If you have a really good thermal envelope, you may be able to heat your entire house with heat pumps. But as we'll talk about, often if you have kind of you haven't been able to make the weatherization upgrades in your home, you may need some kind of supplementary heat. So again, let's talk about that in more detail as we go. But right now, I just want to make sure that's something that everybody knows. Heat pumps do work even when it's really cold outside. which one's right for you, right? As I promised, there are a variety of different kinds, and you want to know in my home what's going to be the best fit for me, what's going to work well. We'll talk about these 4 different kinds. We'll talk about ductless heat pumps, ducted heat pumps, air to water heat pumps, and ground source heat pumps. I think these are kind of a good way of categorizing the different systems that are out there. So yeah, let's get right into it. Let's talk about these different systems in detail. Um, let's first talk about ductless heat pumps. So these are what people commonly think of when we say heat pumps, right? When we think heat pumps, looking at this picture of this system mounted up on the wall, that's often what comes to mind. And as I'll get into, it's often going to be the best solution, right? So for a lot of homes, a lot of homeowners, these are going to be the most flexible option for you. So I'll talk about why that is. I mentioned earlier that we kind of want to discuss vocabulary, right? What do you need to be able to talk to a contractor about in order for them to understand what you're looking for, what you're interested in? You want to be an intelligent and informed consumer. So you should know that these can be referred to in a variety of different ways. Like I said, a lot of people, when they say heat pumps, this is what they're referring to, ductless heat pumps. Um, they may talk about one-to-one heat pumps, mini split heat pumps. I imagine that sometime later in this presentation, you'll hear me just drop the phrase mini splits, rolls off the tongue really fast. A lot of the time when people are talking about mini splits, this is what they're talking about, ductless heat pumps. It's a term that we just use a lot. These systems, as I'll share shortly, they can have kind of different layouts. So someone might talk about these as multi-split or multi-zone heat pumps, but these are all referencing ductless heat pumps. Again, kind of the overview here. Each indoor head, so you can have an independent indoor head, and these indoor heads are going to deliver heat into a single space. So if you think back to kind of our traditional systems that we talked about earlier, the wood stove and the space heater, they're behaving like that, right? They're a single source of heat in one room. In some cases, they'll get some of that heat into other rooms, but you can kind of think about them in the same way that you would think about some of those other traditional space heater type systems. And because of that, typically more than one is required to heat an entire home, right? They're not distributed throughout the entire house. If you have multiple different rooms, you're probably going to need more than one of these. Just a quick photo drop here. I'll talk about outdoor units. So outdoor units, this is what they look like. On the left, you can see several smaller units lined up next to each other. This implies to me that there's 4 single zone systems in this house, right? So each one of those small fan units is associated with an indoor head up on the wall. Whereas this one on the right, it's a bit of a bigger unit. You can see a couple of sets of refrigerant lines coming off of this unit. That implies to me this is a multi-zone or multi-split system. So this one outdoor unit is concentrating the heat and then sending it to 2 indoor units that are in 2 different rooms. Those indoor units, this is a photo I already showed over here on the left. This is what a lot of us are going to be familiar. This is what's going to work really well in a lot of different homes. This unit is mounted up on the wall, distributes heat, and also cools your space as well when you're using these in the summer. Again, a lot of us are super familiar with these. But these units can take a variety of different shapes, so it's worth mentioning those. On the right, I have a photo of a floor-mounted unit. So these can go down low if there's no way for you to put one up on the wall. And then there's also a ceiling-mounted unit. These ones have some kind of trickiness associated with installing them. So work with a contractor, right? Have a conversation with a contractor. They may not do anything but the wall-mounted units. So have that conversation and say, hey, I'm pretty interested in these ceiling cassette units. Can you tell me do you do these, and kind of what are the practical needs around installing these units? But I just want to make sure everybody's aware, because I'm not sure everybody knows that there are a variety of different indoor units that exist. Again, just kind of some of the features of ductless heat pumps. These are very often some of the least expensive systems you can get. They are very fast to install. They can be versatile in a variety of different homes. These are super flexible, right? So I think I led by saying that these are going to work for a lot of different people. They're really flexible. You can put them in a variety of different spaces. They can be really useful for partial fuel switching, right? So if you want to save a lot of money on fuel oil. Fuel oil prices have been going up. You want to save money on fuel oil. you can put in ductless heat pumps and run those 80 to 90% of the time. When it drops below a certain temperature outside, let's say 5 degrees Fahrenheit, 0 degrees Fahrenheit, you let that oil system come on and do the heating, right? So that kind of two system approach works really well, and these ductless heat pumps work really well with that. So if you have an existing boiler or furnace that works well, and it's not at the end of its life, these ductless heat pumps work well and can be a good flexible option for you. For a complete fuel switch, I will say your home likely needs to be weatherized, right? Because these are in single rooms, they're single source emitters in a single room, and because of that lower temperature distribution we talked about, it's usually a really good idea to do weatherization before you try to use these systems for your entire heating system. There are people out there who think that they're going to keep using their old system for supplemental heat, and then they're able to use their ductless heat pumps almost all of the time. There are other people who are really hoping they'll be able to use their ductless heat pumps all the time, and then end up using their supplemental heat still a little bit. You're going to keep cutting into that existing fuel-fired heat if you are weatherized as well. So these pair well with weatherization. As I mentioned, because these are in a specific room, they often require some tolerance for temperature variation. Think back to our original conversation or one of my original slides on comfort, right? What's your comfort need and what are your goals? If your laundry room is down a hall where there's no ductless heat pump, it may be a couple degrees cooler down there. That's something that you have to be anticipating and kind of willing to account for. And then, of course, as I showed with those photos, these are often visibly prominent. I think that's a consideration for some people, so I'll mention that here. Where do these systems work well, right? So these systems are going to work really well for a lot of people, right? They're very flexible. Like I said, they're usually lower cost to install than other heat pump systems. And these systems work really well you can do more of your heating with these systems if your home has a simple layout, open floor plans, few bedrooms, right? Because they're in one room. The more complex or the larger your home, the more of these you're going to need. I will say, some people interpret that to mean you're going to need one in every single room. That's usually not the case. That's not going to be an efficient way of operating these. That's going to have a really high upfront cost. If you have sort of specific questions about your home and your home's layout, definitely you can reach out to Efficiency Vermont. These pair well, as I mentioned, with systems that already have central heating systems that work well, zoned central heating systems, so you can bring down the temperature on your existing fuel-fired system in one zone, have the ductless heat pump operating in there. And then one of my favorite setups is just when you have existing wood heating, right? You have a wet wood or pellet stove that you really like that can do the vast majority of the heating when it gets down below zero. And those ductless heat pumps are going to keep you warm really inexpensively and efficiently most of the time. And you get that wood stove cranked up. Everybody hangs out by the wood stove when it's 0 degrees outside. When it's 0 degrees, you want to be toasty by the wood stove anyway. So I think those systems work exceptionally well. And then, of course, you can add heating or cooling to a particular room. This is especially the case with cooling. This is something that people often go after. You have a main bedroom in the house that you're trying to add some cooling to. This can be a real benefit there. Okay, so I'm going to start moving kind of in the direction of more complicated and larger systems. So from here on out, I'll be talking about distributed systems, right? So those ductless systems, those were sort of like the space heater or the wood stove, as I talked about at the beginning. From here on out, we'll talk about distributed systems, and that's going to come with some increased complexity, some increased cost, some increased size, but it also comes along with a higher likelihood that you can do a complete fuel switch, completely switch over to heat pumps, and a higher likelihood that you'll be comfortable in every room, right? You're getting air distributed, or excuse me, you're getting heat and cooling distributed to all of the places that you bring it to, and that's going to add some comfort to the home. So we'll kind of be scaling in that direction in terms of size and complexity. So now I want to talk about ducted heat pumps. I'm just including a photo here on the right of an outdoor unit. Kind of looks like a traditional AC outdoor unit. Yeah, that's how you can think about it. Let's get into some of the details. So again, thinking about that vocabulary, what do you want to be able to refer to when you're talking to a contractor? People might refer to these as central heat pumps. And I'll add that there are two types. So there are centrally ducted units. That's the photo here on the right. Behaves a lot like a furnace, right? So you've got your outdoor unit concentrating heat, bringing it into the house through that refrigerant system. And then there's that's in there's a unit inside that a fan is blowing across that warm refrigerant and then through the ductwork that's being distributed throughout the house, right? So again, these work a lot like a furnace. And then I'll also mention compact ducted, not as well known. We don't see them as often because they're kind of tucked away. I'll talk about what that means, but that's the photo here on the bottom. Instead of being a central system where you're trying to bring ductwork to every room throughout the house, these compact systems might be targeting 2, maybe 3 rooms with short lengths of ductwork. So again, you're using ducted distribution. That's why I'm categorizing this with ducted heat pumps, but these aren't bigger centralized systems the way that a centrally ducted one is. Kind of throwing a lot of terms out there. In the end, I hope that all of these things are clear because having this vocabulary down is really helpful for being an informed consumer. So some of the breakdown here, what are the characteristics of ducted heat pumps? This is a question that comes up a lot. I think people submitted this question in advance. I talked to a lot of people about this. Can I take advantage of my existing ductwork? So sometimes you can, but it really depends. You'll want to work closely with an HVAC contractor, heating contractor who has experience with this because different ductwork systems can be designed differently, which can allow in some cases, a plug and play application, right, where you swap a centrally ducted heat pump in right for your existing furnace. You just take advantage of the same ductwork that's already there. But that doesn't always happen. Why is that? That's because of that temperature of distribution that we talked about. So that heat coming out of the furnace is really hot and it runs really hard for, let's say 45 seconds and then turns off again. And then it heats really aggressively for 45 seconds with that high temperature. With a heat pump, it tries to just run consistently. That's part of where the efficiency comes from. Just kind of hums along at a consistent speed all the time, blowing slightly lower temperature air. And that change in air temperature makes it so that you may not be able to take advantage of your existing ductwork. But again, if you can, it can make these a really good option for you. So it's worth having a conversation with a heating contractor about that. These units I'll add have inline air filters, so that's great. That can keep your air nice and healthy in your home. And they can be really helpful for reaching smaller rooms, right? Because they're distributed. This is kind of referring to those compact ducted ones. If you have a few little rooms upstairs that you're trying to get heat to, these can be really helpful for that. Typically, because these systems are larger than a ductless system, they can be more expensive. And as I mentioned, existing ducts may be altered, may need to be altered or replaced. So that's going to be the case for a lot of people. Kind of depends how old your ductwork is or what your original ductwork design was. So work with a contractor on that. But if they do need to be changed, that can start to drive up the cost and labor intensity of the project. It doesn't mean that this is not a good option for you. This could still be the right option for you if you like that centrally ducted system and how that works. It's just going to impact thinking about budget, goals, comfort needs, things like that. That's going to change that a little bit. And of course, if your home can't have ductwork, which some homes just doesn't work because of the construction of the home, these obviously aren't going to work well for you. So who do they work well for? I like to start just with one specific example. These work really well in single-story homes with unfinished basements because that unfinished basement, you can put in an air handler and you can put in new ductwork. Doesn't matter what you had already in place. I call this the upside down octopus, right? So I included this photo on the right here, single story home. We don't actually know what's going on in the basement, but if it's unfinished, there's a very good chance that we could put an air handler and ductwork down there and get heat and cooling to every single room without that much dramatic change in the house. Because you may need to change the ductwork, these systems pair well with more robust interior renovation. You're doing an addition, you are switching up some of the rooms, and you'll be ripping out interior finishes. That in that case, you'll have access to the ductwork, and by accessing that ductwork, you'll be able to make the changes that you need to make. Again, there's still the labor intensity, but those things kind of pair well together. And as I said already, they do really well to reach multiple small rooms. So if you're concerned that you have a couple of little bedrooms at the end of a hallway upstairs or something like that, those compact ducted units can be built into a plenum, some kind of drop ceiling in the hallway, and then you can run a small stretch of ductwork into each room. So that's not something that is super common, but it can work really well. So that's a good thing to have a conversation with an HVAC professional about. Again, kind of moving up the scale here, and I'm going to kind of change a little bit what we're talking about. So we talked about boilers already, right? So hot water distribution. Here we're going to talk about air to water heat pumps, right? So this is again a bigger central distributed system. We're moving up that scale, but this is going to be using hot water, so hydronic distribution. That's again part of the vocab quiz. One of the words that's good to know when people talk about hydronic distribution. They're talking about hot water, talking about boilers, and in our case here, we're talking about air to water heat pumps. So air water heat pumps, these are typically going to be a whole house system. Like I said, we're kind of moving in the direction of more complexity, more centralization. You're getting full distribution throughout the house, right? These are less likely to be targeting just a couple of specific zones. Um, and these are a really good option for people who want to have radiant heating, right? I'll say right off the bat that we see these in new construction a bit more because you have a lot more access to what the distribution network is like. Here in a couple slides, I'll talk kind of some of the details about the distribution system. But I know that there are people out there who, for a variety of different reasons, maybe it's sensitivity to the particulates that can be moved around by ductwork, things like that. They may strongly prefer radiant heating. So this is going to be your option there. So air to water heat pump kind of layout here. I'm just including some photos. That outdoor unit, you're still in the name, air to water. You're pulling heat from the air and then you're distributing it around via water, right? So there's that photo of on the left is of an outdoor unit. It looks pretty similar to the ductless and ducted outdoor units that we already showed. There's a fan unit outside. That's where you're concentrating the heat, and then you're going to send it into the house and distribute it around. They can be a little bit bigger, right? You see this one's got these two fans on it because you're doing a lot of the work. You can heat, you can cool, you can hook up your domestic hot water to these. So they can be bigger units. On the right, you can see kind of the piping layout of an existing or of an air to water heat pump system. And as I said, we're moving in the direction of more whole home systems, kind of very good comfort that you're taking advantage of. You're getting really high efficiencies from these systems, but there's additional complexity. So that drives up the cost. And then also you need some space to be able to have different piping setups so that you can distribute hot water to a few different places throughout the home. You may need a buffer tank. There's a variety of different sort of elements that go into one of these systems. So you need some space for it. So that's just worth keeping in mind. Again, you're getting kind of better distribution and really high performance, but it's coming with some additional complexity and cost. Some of the characteristics here, as I said, these are often whole house systems, and as a result, they can be good in new construction environments, or they can, as I said, we're talking about existing homes. They can pair well with big changes that you're making in the home. They can be tied directly into domestic hot water. So if that's something you want to do, you already have your boiler is doing your water heating as well. You can just switch that right over. And these, depending on the design, often can do that domestic hot water heating for you as well. And I'll say it again, and I'll continue to say it throughout. Depending on the home, you may be able to use your existing distribution infrastructure because of the lower temperature of the water. Let's say the boiler, your boiler is probably putting out water in the realm of 180 degrees Fahrenheit. Air to water heat pumps probably putting out water in the realm of 120 degrees Fahrenheit. Still very warm, but the existing distribution infrastructure may not be well suited for that. If it is, and I can give some examples, if you have radiant flooring, or if you have certain types of radiators, worth talking to a heating professional about this, you may be able to take advantage of your existing system, and that's great. That would bring down the cost. These are not typically plug and play, right? So plug and play is the term we use for just take out your existing boiler and throw one of these in, because of those distribution needs that we were just talking about. So if you have a boiler and you have cast iron radiators or baseboard radiators, likely this isn't going to be a direct swap out for you. So you'll have to work with a heating professional. You can call us, talk about your specific situation, but this isn't going to be a plug and play. It can be pretty expensive and time consuming to change your existing hydronic distribution. But as I said, with the ducted heat pumps, that doesn't mean it can't be done. I have a colleague who did it. He's been very, very happy with his system ever since. And so if this is the system that seems best for you, this is getting back to your question about your goals, your comfort needs, and your budget, right? It can be time consuming and expensive, but it certainly can be done. You can change your existing hot water distribution as it goes throughout the house. And then I'll mention that if you want cooling, you have to add ductwork. You can't just run cold water through your radiators. So that adds some complexity as well. Again, we're getting to really high performing systems, but they can be a little bit more expensive. So where do these work well? Again, I said it once before, and I'll say it again, homes that already have low temperature emitters. I include this photo here on the right of radiant flooring being put in, right? So, and there's going along hand in hand with that is homes have to have appropriately zoned distribution. So what that means is that if you have all of your radiators on one big loop, the hot water starts at the boiler, goes through every radiator in the house, and then comes back. That's probably not going to work well with an air-to-water heat pump. So you have to change the distribution as well if that's the case. And these are often involved in more robust retrofits, right? As I said, I've had a couple of colleagues who have put these into their existing homes with great success, but they've aligned them with some more robust retrofits in the home. So we know this can be really successful for people. It can add a lot of comfort. It can be really efficient and save you a lot of money in operating the house. But because they're not a direct plug and play swap out for a boiler, that can drive up the cost a little bit. Lastly, I want to talk about ground source heat pumps. So kind of the big switch here is that we're no longer pulling our heat from the air. We're pulling heat from below the ground. We're using the stable temperatures of the earth to extract that heat, compress it, and then drive it into the house, right? So these systems are super efficient, but as we'll talk about shortly, this added efficiency and complexity comes with the cost. I'll add that people really often refer to these as geothermal heat pumps. I typically refer to them as ground source heat pumps, but a lot of contractors are going to talk about them as geothermal. So worth keeping in mind that those are the two different terms that gets used here. Again, they're using the stable temperature below the ground, and that's even in the depths of winter. It's not the same temperature as it is outside once you get a few feet below the ground. And in the summer, same thing, right? Stays cooler. So that allows the performance of these to go really high, right? These can be super high efficiency systems. They can operate more efficiently than any of the other ones we've talked about so far. But there's added complexity, right? So there's drilling involved. These systems have quite a few components. There's all the outdoor infrastructure, the wells that you have to drill to do this. There's a water pump. There's the heat pump unit itself, and then there's whatever distribution system you have inside. And I'll mention that these systems can be used with forced hot air or hydronic or hot water. This comes up sometimes in conversations. People want to know, can I do either one? Yes, you can. Just depends how you design the system inside. And again, you're going to want to have this designed for that lower temperature setup inside the house. There are a couple of different types of ground source heat pumps out there. There are closed loop systems as well as open loop systems. We typically see closed loop. The vast majority that we see done in Vermont are closed loop. They tend to be more reliable, though there's some kind of changes in technology that are changing some of those things. But open loop systems are taking advantage of water below the ground. Again, that temperature is still stable. You're just pumping that water directly out of the ground and using that. Whereas a closed loop system, you drill that well and then you backfill your pipes with usually a glycol water mix. And then that, just by virtue of being underground, the heat conducts into that mix and then you send it back into the house. And that's how you, again, same technology. You're just concentrating that heat and then bringing it into the house. We're just pulling that heat from someplace else. Some of the characteristics here, right? You guys are starting to sense the pattern. These systems can operate with really high efficiencies when they're designed properly, right? Because you're taking advantage of that stable temperature below the ground, you can provide consistent temperatures and get consistent performance out of your system all year round. These absolutely operate super efficiently, and you don't get that dip in capacity and that dip in efficiency in the depths of winter. As I've said with some of these other systems, if you have low temperature distribution already in place, the right kind of ductwork or the right kind of radiant floors or the right kind of radiators, It can be possible to retrofit these into existing heating systems. But if you can't, again, that's going to drive up the complexity and the cost, and that may drive you back towards some of the simpler options we talked about before. But that doesn't change the fact that you can change your indoor infrastructure to make the system work well for you. Um, these systems are often the most expensive, in large part because of the drilling involved. If you have to bring a crew on site to do the excavation or the drilling, that's going to require certain site-specific conditions. Sometimes it just won't work for you to get a ground source heat pump, so you'll want to have serious conversations with the contractor who does these. What do I need to know? What are all the details I have to keep in mind if I'm going to pursue a system like this? Because again, they're often the most expensive systems, in large part because of that drilling that's involved, and they require more detailed design, right? So if you're going to invest in a big system like this, you really want to make sure it has a good design. You want to make sure you're getting the right amount of heat from below the ground, and make sure that you have the right type of emitters inside the house. Where do they work well? I include this photo here on the right. I don't actually know that many details about this house, but it's just a large house that's probably pretty complex based on the architectural style. It's probably a big layout, right? So these are large central systems, so they can do really well in large homes that have complex layouts, where a ductless heat pump may not be as effective, right? So if you are making significant changes to your existing setup inside, you're ripping out the drywall, and you'll have access to the existing distribution in the house. That can be your real opportunity here to install what you need to make a ground source heat pump work for you. Again, these homes, you have to have a property that has appropriate site conditions for drilling. That is a consideration with these, and that low temperature distribution that we've talked about throughout. Just checking the time here. Want to make sure we have enough time for Q&A. A quick summary of that sort of scaling in systems that we've talked about. Ductless heat pumps, these are decentralized heating, behaving more like a space heater or a wood stove. So there's no distribution, but as a result, there's low complexity and a relatively low cost to install. These are really flexible systems. You can put a few in the house, you can coordinate them, and that can be really effective for a lot of people. The ducted systems, again, you're getting that distribution throughout the house, so that can increase complexity, but it can also increase cost. Air to water systems, same thing, right? These are central systems. You're using hot water to distribute throughout the house. The complexity depends a lot on whether you can take advantage of your existing emitters, your existing radiant flooring, for example, or not. That's going to impact the cost and the complexity. Ground source systems, again, these are central systems. They can be either hot water or hot air. It's fair to say that these are the most complex and the costliest, even if you don't have to redo your indoor infrastructure because of the drilling involved, tapping into the sort of stable temperatures below the ground. That's going to drive up the cost and the complexity. Something to mention here is that this also pairs with contractor availability. So another reason that you may lean in the direction of the ductless systems is that they're really common, right? There's a lot of contractors doing them all around the state. As we kind of move up this scale of complexity, there are fewer and fewer contractors, so there may be a longer waiting list. If you're going to go with one of these big central systems because it's the right system for you, great, that can work super well, but that's just something to keep in mind. I'm going to return to some of the stuff we talked about at the beginning, just so you kind of remember what we want you to walk away with. I hope you got some good vocabulary from that, some good details about how these different systems work and where they might work best, but some of the breakdown of what's going on. Sorry, I think I went backwards a slide. Okay. So revisiting these original questions, right? What are your goals? When I was talking about those things, were you like, yeah, I really want a brand new central system, I'm planning to make big changes on the house? Or were you more like, I think I want to get a little bit more efficient heating, and I could really do a couple of ductless in a couple of rooms? I think that's a really big consideration. Comfort needs, again, the same thing. How much do you need that heat and cooling distributed to every room of the house? I won't talk too much more about the distribution system because and what your house is like because we talked about that quite a bit. But just a quick reminder that weatherization does matter. The building shell is going to change what system works best for you. So that's another thing to consider. And lastly, of course, what's your budget? As we talked about, these systems as they get more complex and they scale up, their performance goes up, the comfort goes up, but the cost goes up with that. And lastly, I'll mention questions to ask a contractor, right? I promised that I would talk about these things. I think these are 4 questions that are really important to ask. What type of heat pumps do you install, right? You don't want to get into an hour-long conversation with a contractor and say heat pump, heat pump, heat pump, and you're talking about ground source and they don't do those, right? So make sure that you talk about that in detail. Do they bundle heat pumps with weatherization, right? Are they thinking about the building shell when they're thinking about these systems? Some contractors do both. A lot of contractors just do one or the other. So it's a good thing to keep in mind. What are you going to do to determine the heating load and sizing for the system? So that matters, right? Well, you want to make sure that you're not getting too large of a system, too small of a system. So making sure that they're getting the right size really matters. As I think I talked about throughout, as we increase in complexity with our systems, we get closer to those air to water and ground source heat pumps. You're going to want to especially look for them to be doing full scale load calculations on the building with the ductless heat pumps. Maybe that's not quite so important, but have that conversation with them, right? Ask them, what did you use to calculate the size of the equipment that I should have? And again, I said it a lot. Can you take advantage of your existing distribution infrastructure? If you can, that's great. That's a huge advantage. It's a real boon, and it's something that you should do. If you can't, no worries. There are still alternatives out there. You can go with the more flexible ductless systems. You can change your existing infrastructure, but that's just a real consideration to keep in mind. To get started, you're welcome to reach directly out to us. We have technical consultations that we can do over the phone. You can use our Find a Pro tool online to find a contractor that will work well for you. And we also have a lot of rebates for these systems. The rebates kind of scale in how much they are proportionally to the cost of the systems, as we talked about. So that's something to keep in mind. Definitely check out our website for all of those, all of that information. And I'll add as well that there are financing options that we offer. So check those out on our website. You can get really low interest loans to finance large projects. And so if you're thinking about that you want to do one of these larger systems, but it seems a little out of reach, we do have financing options through partner organizations as well. So feel free to reach out to us about that. We're happy to answer any questions. And yeah, check out our website for those details as well. Okay, thanks very much. I hope I saved enough time for questions, about 10 minutes here. So I hope that was informative for everybody, and I'll let my colleagues take it away.
Awesome. Thank you, Nate. Nate, can you hear me okay? Just double checking. Great. Thanks for that awesome presentation. And thank you everybody for submitting the questions and keeping me very active on the sidelines here. In the closing minutes here, I just wanted to run through some of the questions and answers. I tried to get to as many as I could. As the chat was going along, there were some really great questions and some that would provoke an even longer discussion. So I tried to just give the short answer there. And if you want to talk about it in more detail, please feel free to reach out, and you can reach our customer support team and they can talk with you, or they might put us in touch with somebody like ourselves and we can talk about it in more detail. There were a number of questions that were submitted ahead of time, and I want to try to get through a couple of those. I'm not going to get to every one, but I'm going to just hit some common themes. Starting out, there were a lot of questions around efficiency and capacity and how that might change at different temperatures. And one thing that I would encourage you to do if you're interested in that and diving more into that, the manufacturers do publish their capacity ratings at different temperatures, and they also publish their efficiencies. The terms that you can look for are the SEER or the SEER for their seasonal cooling efficiency, the HSPF or the heating seasonal performance factor for their heating, the seasonal heating efficiency, and then the COP, which is the coefficient of performance, and that is the efficiency at a given temperature. I won't dive into the details on those specifically, but those are kind of the metrics that you look at to be able to compare these different models and see what temperatures they work down to. Generally, they get posted at temperatures like 47 degrees, 17 degrees, then you'll see ones at 5 degrees, -5, -13, something like that. Somebody had a great question about efficiencies of window AC units versus ductless heat pumps, and generally ductless heat pumps are more efficient than window AC units. And what they are just in their kind of technology itself, but also the setup where you don't have that big opening of the window through the wall, so you're not losing heat through that opening. And they also can just provide a lot better conditioning with a fan that can distribute that heat better into the space. So there's some additional benefits there. Also had a question about common backup systems. I think Nate covered that pretty well. We definitely see existing heating systems used often. Sometimes people will, if it's just supplemental, people will add a little bit of electric resistance in key areas. That could be in with electric baseboard. Sometimes it's also electric resistance coils for ducted heat pump units. And then a lot of people also choose to have wood stoves as kind of a supplemental system or a system in place in case power does go out. And then we also had a question about adding additional heat pumps to an outdoor unit over time. Nate touched upon the differences between single zone and multi-zone units, and I think that's something we could talk more in detail about, but generally I would say you can add you can have multi-zone outdoor units that could have multiple indoor units, but if it's not something that you're planning on doing in the near term, you might want to consider asking a contractor about doing single zone instead. There were some really great questions around the upfront cost and the savings associated with heat pumps. The upfront cost question, I think that's best directed to contractors. They talked about a lot of different systems here that do cover a lot of different price ranges. So I think that's a conversation that it's great to just talk to contractors and get an understanding of prices from them, depending on what specific system and what kind of installation you're going for at your house. And then from a savings perspective, that's something that we're also happy to talk to you about in more detail. It depends a lot on what your existing fuel source is and what your existing system efficiency is. And then, of course, it depends on the heat pump efficiency and what you do pay for electricity. But a lot of that question around how much they're going to save you depends on what you're paying for fuel and what kind of your existing system that you're switching from is or that you're adding onto is. Generally speaking, we're seeing oil and propane and electric resistance heated homes finding significant savings from switching over to heat pumps. If you have something like a natural gas system, that's a relatively cheap fuel already. So the cost savings are smaller, but then kind of look at things of are there comfort benefits from heat pumps. If you're interested in diving into that more, Efficiency Maine has a great heat pump or home heating comparison tool. So I encourage you to check out their Efficiency Maine website for that. There were some great questions about finding contractors. Nate mentioned there's a Find a Pro page on Efficiency Vermont's website. So that you can select there and click on the type of heat pump that you're interested in. So definitely use that as a starting point. And there were also a lot of questions about financial resources that also came up in the chat. So Efficiency Vermont has rebates for these heat pumps, as Nate mentioned, and loan financing programs. There are a lot of questions around the Inflation Reduction Act, and that's something that the tax credits are available now, but there are rebates also that are kind of being developed that the state is currently coming up with a plan for how that's going to be implemented, and we're hoping it comes out in 2024, but we don't have a great insight of when that will be just yet. I did post in the question a couple of FAQ pages for that if you're curious about looking into that a little bit more. And then we had a great question around the placement of an outdoor unit. The outdoor units, you have them elevated so they're not dealing with snow cover. And this question specifically was wondering about how to protect it. And sometimes they have little roofs that are built over the unit in case you can't protect it, in case it has to be under the drip line of the house. You generally want to keep it away from that. So sometimes they'll build a small roof right above the outdoor unit. And then we did have some questions in the beginning or before the webinar about heat pump water heaters. While this presentation was focused on space heating, heat pump water heaters can also be a great option too. And if you want to discuss that in more detail, I'd encourage you to reach out to us for those as well. And just recognizing that we're coming up on time, I think I'll I'll stop it there and thank you all for being here, and kind of reemphasize one more time that if you do have questions that we didn't get to today, please feel free to reach out to our customer support team and kind of get those questions answered. And yeah, thank you all very much.
Thanks, Bennett and Nate. I just want to thank everyone else who joined the call today and for sticking with us through the entire hour. You guys had great questions and engagement. I'll just note that we did have some questions coming in at the very end. We can do our best to get an answer to you, and we'll also share out the Q&A so folks can kind of review that if they weren't able to kind of keep track of it while they were listening to the presentation. And we'll also send out, that email with the slides, recording, Q&A. So you'll have it all there. And again, thanks Nate and Bennett for sharing your time and expertise with this group, and especially, Bennett for typing away those answers during the presentation. So thanks everyone, and have a great rest of your day.
Thanks, Becca.
Thank you, Becca. Thanks, everybody.
Thanks, everybody.